My name is Marissa Lubeck, and my presentation today will be on manatees, better known in the scientific community as trichechis. Manatees inhabit rivers, bays, and coastal areas, moving freely between fresh, saline, and brackish waters. These different habitats provide extensive beds of seagrass and abundant freshwater aquatic vegetation that provide the manatee's primary food source. Manatees can be best described as a semi-social breed. The basic social unit is a female and her calf. Groups of manatees gather and disperse casually. Here is an image of an umlaut of a manatee. Manatees display rhinotaxis as they move with the current of the water. They also display orthokinesis as they change their speed of movement to get to the surface for air. At times, they can even exhibit phototrophism when they direct themselves towards the surface of the water for some light. If a manatee were to be dropped from the Empire State Building, I could safely say it would not survive. As for temperature change, cold snaps caused by unusual water temperature fluctuations are killing manatees. A drop in the climate temperature by 5 degrees Celsius would make it rather hard for the species to survive. Manatees need to be in water that is no colder than 68 degrees Fahrenheit to maintain a safe internal body temperature. If the water gets any colder than that, they may get what is called cold stress, and this is in turn what makes them vulnerable to disease and death. On the other hand, if the planet were to be warmed by 5 degrees Celsius, I do not think the manatees would be as negatively impacted. It still would not be the best for their survival, as I am sure it would impact their environment and possibly alter the marine life around them. It could also potentially impact where they migrate and if they choose to stay in different regions to keep cooler. There are no specific studies on the effects of cadmium on manatees, but long-term exposure to mammals could result in harmful effects. If manatees were exposed to atrazine, we would see a lot more birth defects in the liver, kidney, and heart damage in animals exposed to high levels. My scientific question I would like to look into is how often do manatees rise to the surface for air, and how greatly does this vary depending on if the manatee is a child or an adult? I believe this question will be something good for us to observe, as it does not require us to have a camera in the water, and it is something we can view from land. I hypothesize that manatees will come up for air approximately every 5 minutes. I also hypothesize that the young manatees will have more of a need for air because they are exerting more energy, so they will rise to the surface more often than the adult manatees. This question I'll be studying is mainly encompassed in Timberg's question about mechanism, or the cause of behavior, the physiological need for air. Since we will only be observing the manatees from land, and I will not need to obtain a camera to rest in the water, all of our behaviors for the ethogram have to be something we can view from above the water. Here's what our behavior list will look like for the sample. The best way to observe these behaviors would be to do an instantaneous scan sampling to see specifically what times the animals rise to the surface. Here is an example of that below. In order to enhance the quality of our observational data, not only will I be recording data in live time, but I can also have a camera recording while I'm observing the behavior so I can go back and watch the footage later as well. Thank you for your time.